Yeah, audio is good.
Okay, so good morning, everyone.
Yep.
All good?
Yep.
Yeah. I'm just going to get started. Just going to be about 45 minutes before you guys go over to your next phase of your induction. So I'm going to be taking you through 3D printing 1, and then in the afternoon we're going to do 3D printing 2. This stuff is going to be a lot of information. This first one, and then the next one's going to be a lot more stuff to do with exercise and stuff like that. But it's pretty self-explanatory stuff. It used to be a lot more difficult, but now it's a lot more plug and play. So you just literally cut your design, put it in, and it's great. So the 3D printers are really good now, and the slicing software is really good. So yeah, let's start with an overview. So what is it? So we know 3D printing is an additive process. So build a model layer by layer, right? And so it's a culmination of many thin 2D layers that build up to form a 3D object. Obviously, it's not 2D exactly. It's got a very thin 2D layer, very small height to it, but that builds up to form the 3D object. So we talked about this yesterday, but the three types of 3D printing that we're used to is fused deposition modeling, vat polymerization, which is also known as like resin printing, and then selective laser sintering. So fused deposition modeling is the one we'll use mostly. So it's the most common type, and it involves the extrusion of thermoplastic polymers. So that's your filament that adds a deposited layer by layer. And here we just have a picture, an example. So it's building it layer by layer, and then you add it to the other part, and then it makes it. Okay, the next one is vat polymerization, also known as resin printing, stereolithography, and digital light processing. So this is also a layer by layer, curing of a vat of photosensitive polymer. So a resin by a light source. And usually this is UV. And so it builds it from the bottom up. And it's usually for highly detailed and intricate designs. So this is used a lot in medical design and NIDA printing, just because it can get really fine channels and it can print without the need for many supports. So here's an example. So it's building up from the bottom and it shoots that light and cures the resin. Okay. There's a lot of post-processing involved with this one. So you have to put it through a curing chamber and then put it through like an ultrasonic cleaner as well to get rid of that extra resin. Okay, but the next one we have is selective laser sintering. So it involves the use of a high-powered laser that selectively heats up and fuses a polymer powder together. And it's used more for industrial design, especially metals and stuff like that. So here we have an example of making a gear here. And then it will comb over and deposit new powder on top of it. And then build that part. Okay, and so back to the fused deposition modeling printers. So 4 types that we have mainly used to. There's a lot more, but the ones that are commonly used are Cartesian, Delta, Polar, and conveyor belts. So Cartesian is the most commonly used design. Its build plate is connected to the Y plane, so it moves back and forth. Okay, whilst the extruder is connected to the X plane. So that means it goes back this way. Okay, which is also connected to the Z. So as it goes up, the X moves along with it as well. Okay, a Delta printer is using 3 independent rods that are connected to the extruder. Okay, so this individual movement of each vertical rod, okay, allows the printer to move freely everywhere, the print head. And it's used for fast and tall designs. The reason why it's so fast, so this can reach up to speeds of 2000 millimeters per second. So that's pretty quick. And the reason why is because on that extrusion head, right, it's just the extruder. There's nothing else on it. There's no motors. There's no other motors for like the extrusion of the filament. Okay, and then Polar is one that we don't use much anymore. So it uses a rotating build plate to cover the X plane, but also some of the Y plane. And then its main benefit over everything else is that smaller footprint it has. Due to that, there's no need for that overhead gantry, as you can see there in that little picture. And then the one that is kind of a Cartesian sort of not is conveyor belt. So conveyor belt acts as an endless build plate in one plane, depending on the model being printed. So the extruder is angled at 45 degrees to accommodate for that belt moving across. Okay. And it's used for tall and long prints and for creating a long supply chain. So you can print an endless amount of Lego bricks, like this example here. And then here's another example of it. Of it just printing a long sword. And you'll see this in Makerspace, they have one actually, and it always is constantly just churning out parts for them. Okay, so breaking it down into a Cartesian, okay, because we'll be working mostly with the Prusa. Okay, so first of all, we have the filament. So the filament is that material that'll be heated up and extruded to make a design. There's many different materials, I'll go over them in the afternoon, but the main one we'll be using is PLA. Okay, and then we have the extruder itself. So this sits on the X gantry, okay? So the X gantry is this one here, and then the Y one are these two poles here, okay? And this contains the extruder. So the extruder is this bit here, okay? The motor here, and then the hot end here with the cooling fan. And the reason why you need the cooling fan is because if it didn't have that cooling fan, the filament would actually melt, okay? In this bit here, between the motor and the hot end here. So that's the hot end where the filament comes out, and you don't want that material melting up there. Otherwise it'll clog it all up. Okay, and then next we have the build plate or print bed. Okay, so this is where your design is printed onto. It's heated, okay? For different materials, it has different heating properties, different heating temperature, and it has a magnetic coated powder coated spring sheet. So it used to be glass, and back in the day, you used to have to use a glue stick and either put masking tape on top of it as well, just to make these things stick. But now it's really, this spring steel sheet's really nice because it's magnetic as well. And then you just, to remove your design, you just take it off and you break it, you bend it, and it just snaps right off. Okay, and then the motors. So these use stepper motors, which move in the X, Y, and Z plane, and obviously that stepper motor for the extrusion as well. Okay, so rather than a normal motor that you're used to, that continuously rotates, they rotate in angular steps. And that means that they can measure their position really precisely and move really accurately as well. So here's an example of that. So it moves in a very small increments, and it can measure how much it's moved. So this is really important for getting those exact coordinates, especially for 3D printing. Okay, so on to exporting your design. So I want everyone to open up Fusion right now and grab a design they want to take. That can be the Lego brick or something from today.
Okay.
Work out well.
We're missing. If you Ryan and someone else.
Yeah.
And so I have it here.
Okay.
Right.
Like you just.
So first of all, what is our goal?
Mine's
Okay,
he didn't work.
So we want to take our
So he's
Fusion model and simplify it into its basic surface geometry. Okay, so this is also called a tessellation. Okay, so this will make a more universal format with a smaller file size because we don't need all the internal information that's happening. We just want to map the outside of it. There's different formats, but the main thing that we want to remember is that we only want to export our design at the end when you're about to print. Why is that? Because
Drum rolls.
working.
No, is it not working?
Why? Because when we transport it to each step. So we go from Fusion to STL, we lose information, and then we go from STL to Scura, put it in a slicer, and then transform it to G code. We lose way more information. So we can't go backwards. It's only a one-way step. You can go backwards, but you lose so much information that you don't know what's happening by the end of it. Okay? You can go from STL to a Fusion design through a mesh, and that's really helpful for when you want to reverse something and want to edit it. But going from G code to an STL and then back to a Fusion design is basically impossible. Okay, so there's 3 different file types that are most commonly used. The standard tessellation model, or STL, 3MF, and object. So STL is the most widely used 3D model format, but it only saves the surface geometry of the model. And this creates tessellation, like I said before. So it puts it into triangles. So you see here, this would be a sphere, right? A sphere, right? And you can see that there's different levels of, I guess, refinement, we'll call it, that calculates and makes it more refined based on the model. But you see how much information we lose, potentially. 3MF is an update on the STL, trying to address its shortcoming. So one of the main things it does is it uses freeform curves. So if you think about the Fusion spline function, it kind of does that with it, okay? And this can really help add definition refinement to that tessellation. But it can also store geometry, color, texture, and really important for industrial manufacturing, it can also store your printer and slicer settings as well. So when you export that file or the slicer, an STL file, it can save those printer and slicer settings to give to your manufacturer that can then print those settings automatically. The next one is object. So this one's mostly used for graphics design. So it also has those freeform curves to create the tessellations. And it can use polygons instead of triangles to create those tessellations as well. And it can also store data about color, texture, material. Okay, so now exporting from Fusion. So back to Fusion. Okay, so first of all, we want to get that Lego brick demo or whatever you made, like I said. Okay, and we want to combine our bodies that we want to print. So we will always have to make sure it's in one body or component. And if it's not, you have to use that combine function to put it into it. And you can look on the side here in the bodies and then make sure it's just all in that one. Okay, yeah. So you just click that combine.
Also, don't worry, the combine function shows up in your parametric timeline and you can always reverse it.
Yeah, you can always undo it off.
It's not a one-way step, so you can always go back.
Yep, so once we've done that, we want to click that utilities up the top there. Okay, and we see that little make button there. We want to click that. Yep. Once everyone's done that, okay, we get this little format here, this little pop-up that says 3D print. So we want to choose STL ASCII instead of binary. Okay, binary is just well, it's like binary code, it's much harder to read, whereas ASCII is a much easier format. Let me unlock it. Okay, the next thing we want to do is click that preview mesh just to see what it looks like and see our definition. Okay, usually refinement option, medium is enough. Okay, you won't need anything more than that. However, you can just fiddle around. Sometimes you have really complex models and that high refinement is needed. Okay, and then in that output, and in that output, we want to untick that send to use print to use 3D utility. You want to untick it.
Untick to what?
Send 3D print utilities.
Okay, yeah.
Oh, I didn't know, sorry, something.
Yeah, thank you.
It's like one bell. I mentioned it.
So I think one
Right now, I'm really getting it. My mistake is important. I feel like it's
Yeah.
They've also been in my parents' house, so.
Okay, so once we've done that, yeah, once we've done that, okay, we just want to click that OK button. Okay, and then that will save it, and then we want to save it to somewhere.
No, you don't. Save it pretty quick.
It's really good to name your things iterations and have a separate folder project for it as well when you do save it. Yes, as an STL. Where?
Yeah. Normally don't save it to the cloud.
No, I save it to like separate project.
Yeah, it doesn't changing it so much. That like.
I mean, but you have to make one V2.
Oh, that's true.
What's that called? What's that called?
You can try that as well, yeah. Yeah, it doesn't matter. As long as you know where, the main thing is as long as you know where to find it, then we go secure. Because that's what you need to open it again.
Being careful.
Yeah, you can choose. You can make a folder called like SQL.
Okay, great, yeah. So now on to Cura, so we want to open Cura now. Okay, and then we want to upload our little file. So in the top left, you have that little folder. Just want to find it. And then upload our STL file.
It doesn't have to be the coordination. I'm the having seen.
Yeah, you can choose where to go just now, like if you saved it, you just pick where you want. It's automatically down. Oh, yeah. So you want to click on make.
Okay.
I've done all that. Oh, okay, so just sure.
Pictures are showing up.
I wanna. Have you not looked here? Oh, okay, no.
Okay, doesn't work.
It's not bad.
UL.
Okay, so we want to click on the object we just put in. So we want to go in that file and then find that file we just saved. Okay, and then on the side panel on the left hand side, you'll have a bunch of different options. There was pictures for it, but it's gone. But there's move, okay, which lets you move it around that build plate. Scale, play around with these. Scale, which makes it bigger and smaller. Okay, rotate, and then mirror. Yep.
What's the red for? That's not good. I'll be red.
Oh, okay.
So red's for stuff that needs support, but I'll talk about it a bit later. The main one here is scale. So when we design a fusion, right, we design it to an accurate dimension. However, when we're printing, we might need to make it bigger or smaller just because of the material that might expand or might shrink a bit afterwards. So instead of changing the dimension in fusion, we want to change it in Cura instead, because we want fusion to be the most accurate it is. Usually with PLA, I usually scale down a bit. Depends on the model though. Because like if it's a really Like you just have to print something and then you go and
Moves, yeah.
so it's like if you're doing pop, just roll it down. So yeah, with the scaling function, usually it's you print it first and then you
X, Y, and Z.
see how your current model is doing and then you adjust accordingly.
Yeah, I think so.
Scale rotator.
You want to scale it down?
It depends. So like I said, your model will either print maybe perfectly,
Yeah.
a bit bigger or a bit smaller.
Okay.
Okay, and then we don't want to adjust it in fusion because it's most accurate, right?
Yeah.
It's the dimensions that we know.
Yeah.
We don't want to change it. We change this purer then down just to adjust on the printer itself.
Yeah. What are some good dimensions of the printer?
What do you mean?
What's the range? What's too big? What's too small?
Look, like you usually just print it true to form,
Okay.
okay, first, and then go off that.
Alright.
Okay, if it looks, well, if it is smaller. Because it really is printer dependent and material dependent.
Yes, you were saying the same.
Ah, okay. But we don't need to.
Okay, once everyone's had a play around that, we can move on now. Okay, so if we open up that little tab on the right hand side with the little arrow, click that down. Okay, that gives us our basic adjustment menu. Okay, so this will have profile, infill, shell, support, and adhesion. Yeah. So we're just working with the basic ones now, but we'll go into some more custom ones later on. So first of all, we have profile. So this changes the Z height or the layer height of the build, which determines the quality of the build. So in this example here, we have one with a really fine layer height, okay? There's probably 0.15, for example, okay, which is this 0.3. You can see how much more definition we get with that smaller layer height. Okay, so these are the profiles that you get when with a Prusa. Each printer is different, okay? But normally I recommend, okay, normal, draft, and extra files. Okay, and then the next thing we have to remember is quality is proportional to print time. So if you want to increase the quality, that means you add more layer height, which means that it's going to spend more time on each layer. Okay, so that's going to increase the print time. Next thing that we have is infill. So we have two things from that, is that infill density and infill pattern. First of all, the infill density, okay? So Rick's getting out some examples here that I'll pass around, but it's the exact same as these ones. So infill density is percentage of the interior space that is filled with a specified padding, okay? And this adds strength, rigidity, and it helps the attachment of the top layer of the print, okay? So, yeah. And going around with some examples that are printed, different infills. Okay, and you can switch the sides, especially one that 5% one, and you can feel how much weaker it is. It flexes on the inside, you can see it flex. Whereas if you squeeze that 60%, it doesn't move at all. Okay, and then the next thing that we talked about is infill pattern, okay? So this one, the current example is going around, is called grid pattern, and that's what I recommend using for now. Okay, so the pattern is the design of the infill, okay? So different infills are used depending on the requirements of the model, okay? So if you want rigidity, you have to use different ones. If you want flexibility, you have to use different ones, okay? If you want strength in one direction or a different direction, okay, you choose one infill over the other. Okay, if you want a quick infill or you want a flow infill, okay? And so we'll talk about it more in the next session, but for now, yeah, like I said, use grid, because these are all the ones you can do. And so the next thing we have is shell, okay? So this is the exterior thickness of the exterior sections of the model or outside the wall. Okay, so there's an example here. So we have 0.4, 0.8, and 1.2. Okay, you can do this in either size or number of layers. Alright, so it's pretty self-explanatory. The thicker it is, the more strength you have, the longer it takes to print as well, and the more material you need. The thinner, less strength, shorter time, less material, and it's more translucent. Okay, the main thing with this one is that you have to match it to the nozzle size of the 3D printer. Okay, So all the Bruces will be at 0.4 nozzle size. So that means you have to increase it by 0.4 increments, okay? Support is that next one. So some of you might have noticed on your design that it has that red underneath, it has a red zone to it, okay? That means it needs support, okay? So that's when the build has overhangs or really steep inclines, okay? Because if you think about it, gravity will try to bring it down because it's a hot material that's kind of melting, okay? It's not a solid, so it'll try to sag and drop, okay? So then it wants to support these overhangs by generating support. And then these can be torn off very easily, not very easily, but somewhat easily after the print is finished. Okay, and that next one we have is adhesion. Okay, so adhesion, you can have 3 different types. You can have skirt, brim, and raft. Okay, so it helps to build, adhere to the build plate. Okay, it stops the warping of the piece. Okay, and it cleans out the hot end before starting the print as well. The general rule of thumb for right now is that you have a more contact area with the build plate, you want to use a brim, okay? To get more contact area so it doesn't unstick itself, basically. Come on. Okay, if you have a large contact area, you don't have to really worry about it. Okay, so you just use a skirt. Okay, so for like example, probably that Lego brick, I would use a skirt. Once we've all fiddled with those settings, okay, we're going to hit that slice button. Okay, and then this will transform it into G code.
Wait, I'm sorry, 11 hours and 41 minutes. Why is mine?
Yeah, so you can get slice. So yeah, just like one. And then
40 grams.
Oh, mine's like 100 grams. That might explain.
One naturally generated support. Which is totally fine. I think he'll go into what's a little bit. You're talking about trees. Yeah. No, I don't think. Yeah. But you can 3D print it before, right? So.
I believe that resin.
Yeah.
Oh, wait, we can like, oh, you can play the video of how it's gonna print it.
Yeah.
Oh, why is it? Oh, is this backwards? Oh, wait.
Okay, and we hope. Yeah.
Well, we'll lose support, bro.
Yes.
Getting it more.
See what when doesn't.
That's
So do you have the pictures, right? Yeah. This is the different questions since.
Please say what's this?
You wanted to say what it was.
Oh, no.
Yeah.
Like this one.
These files are really quick.
Yeah, it was still, it's too much.
Put 20 space.
20, what are you doing?
Oh, okay.
You told us.
So you need to get the.
No, that's.
Alright.
Yeah.
Just what it looked like. So you can zoom in.
Saying different.
So we can adjust, you can see, so that if you see everybody, and we tell you which one each layer is. And then you play the, getting on the spot, that's what it's saying.
Yeah,
So sure you like.
yeah, layer by layer.
Yeah. And it's printing that fast as well. So I don't know, you might need to change the settings, to make it much slower. That's pretty fast.
Yeah.
Wait, can I see what overview your speed on?
Oh,
Speed
mine
was at
says that
60.
there was an error when I tried to say.
I think I might just
Can
be
you
the.
go with the
might just
design?
be-
No,
Definitely a computer.
yeah, I feel like, yeah, that is.
Okay, great.
Okay.
So I can't save it because of this. And I don't know if it's just like this is.
Yeah, that's.
or my computer.
Oh, yeah, man. It says here, 2 grand. 183.
And you have to allow Kira
Is it setting,
to edit the
like
file.
settings? Like go into settings?
Okay. I'm going to continue on now. So when you slice it and save it, it'll save it as a G-code file. And you can't open these G-code files. Okay. But what is G-code itself? So G-code is a standardized code for CNC machining and 3D printing. Okay, so the code is read by the computer on board the 3D printer and tells the motors where to move, how fast to move, and what path to follow. So it's like normal code, if you remember the coding course from the other day. So it has command and parameters. So I'll go through it all here. So this is a sample one of the brick that we printed. Okay, so it has these settings here. Okay, so M is a command function. And it tells what to change. So it wants to change the temperature of the extruder here, okay? And then S sets the temperature, okay, to 200. So that S200 there, okay? Next, we have a G. So G is also a command code, okay? And then G1 tells the printer that it wants to perform a linear movement, so in the X, Y, and Z plane, okay, with an extrusion as well. So you have to include that E. So it wants to extrude the motor or the filament. Okay, so then we have the X, Y, and Z coordinates. Okay, so it tells the motors to move. Okay, so to the coordinates, and then E is that extrusion. So at the same time the motor's moving, okay, it's feeding that extrusion, okay, that filament into the extruder and heating it up and pushing it through the hot end. Okay, that's how that distance there. Okay, so these are all coordinate-based systems. And that last one we have is that F1800. So that means the speed. So this is all done at a speed of 1800 millimeters per second. Not second, minute. Okay, and then you have at least, I don't know how many lines or whatever this is, of telling it different coordinates, different layers, different Z lines. Keep on going, keep on going. Keep on changing temperature and anything like that. Okay, so with the G code, okay, so what we want to do is don't directly save it to the SD card or USB, okay, because there's an SD card or USB slot in the 3D printer that you have to transfer your file over to. Okay, so we don't want to do that because especially at Makerspace, they delete them all the time. Okay, so you'll lose your G code. Okay, so save it to your computer first and then name it accordingly. Okay, so we want to save it to the project folder and then copy it. Okay, and then we want to make sure the SD card or USB is in fact 32 format because that's what the 3D printers can read. Yeah, okay. So this is what you're going to be learning at Makerspace a bit later, but I'll just go through it really quickly. So we're starting the print, okay? There's a few things we want to check beforehand, okay? So we want to check that the printer is on the level surface. Okay, there's nothing blocking the X, Y, and Z axes, okay? We want to make sure there's no flammable materials around, especially since that we use isopropyl alcohol to clean the build plate, okay? And the bed is level to the eye, and the build plate is clean. Okay, next step we want to do is calibration. So we want to calibrate the 3D printer. Okay, so basically what it is, it's saying 0 point. It's like a tear off for a scale. Okay, it tells it where a home is. Okay, so it calibrates the X and Y, Z, the X and Y first, and then it calibrates the Z axis all over the build plate. Okay, this is to account for the unevenness or the unleveledness of the build plate. So we'll go around at 9 different locations and measure the height at all those locations. I had a nice little picture of the mesh bed leveling, but that's all right.
Yeah. You see that?
Alright, so that's it. It is fine, that's what it's thinking the bed is, to make it level. So as it prints, it will move up and down the axis to adjust for that uneven bed. This used to not exist, and you used to have to make sure you used to go around with a piece of paper and go to all the different locations and put it underneath to make sure the bed was level. And that would be the most painful thing. Otherwise, nothing would adhere. Okay, after that, we want to start.
SD card because they are
So
tested.
here we have.
So now we will start the print from SD card, which is placed here. So just go to the menu and select print from SD. And the first print we will do is Mark III PLA Prusa, which prints a small badge with the Prusa. As the printer was preheated, it should start printing immediately. Again, the printer does the mesh bed leveling first. Then it starts with the intro line and moves to the print.
That's it. So any questions? Great, that's a good job. We are all ready to go print now.
Yeah, so a little bit of sort of background as well for 3D printing, but this is sort of like the hello world of 3D printing, which is called Benchy. So you're gonna actually see this quite a lot at the Makerspace because they have like a whole row of them at the top. But yeah, just something to be aware of, and this is sort of funny as well. I saw that someone built like a person sized boat or something like, yeah, for Benchy, which is a huge ass Benchy. Yeah, so take a look at that, but that's what most people sort of use as their stress test for their 3D printer. Yeah, see if it works properly.
And does each group want to select a design they want to print, preferably 2 hours or 2 hours-ish?
Within 1 hour.
Within 1 hour?
Within 1 hour.
Within 1 hour that they want to take to make space to print. After they've done their.
What do you have?
It could be the night, it could be the nights you guys did, it could be Lego brick. It could be anything. Wait.
Yeah, I really do that.
Yeah.